before the beginning? What came before the Big Bang? One of the greatest mysteries in all of science is this: did anything exist before the universe? The Big Bang theory tells us that around 13.8 billion years ago, our universe burst into existence from an unimaginably hot, dense state. Space expanded, temperatures fell, and the first particles and atoms formed. But what about before this moment? Was there a before at all? Or did space and time themselves begin with the Big Bang beyond, which our current physics cannot reach? For centuries, scientists and philosophers have wrestled with this question. Was the Big Bang the true beginning, or just one chapter in a much grander cosmic story? In this journey, we'll explore what modern science can tell us about the origin of time, uncover new discoveries about the early universe, and venture into bold theories that reach beyond the Big Bang itself, the birth of everything. According to our best models, the Big Bang marks time zero, the instant when all space, time, energy, and matter emerged from an initial singularity of infinite density. In less than a heartbeat, the universe underwent inflation, expanding faster than light in a rapidly stretching space. 1 second later, it was a searing soup of particles. Minutes later, the first light chemical elements formed. But the universe was still too hot for atoms to hold together. Light couldn't travel freely, was trapped in a fog of free electrons, scattering photons. Fast forward to 380,000 years later, the epoch of recombination. Electrons combined with nuclei, atoms formed, and light could finally move unimpeded. This ancient light, discovered in the 1960s and mapped in extraordinary detail since, is a baby picture of the cosmos. It shows tiny fluctuations in temperature seeds that gravity would later grow into galaxies, clusters, and the vast cosmic web. New eyes on the early universe. In March 2025, scientists using the Atacama Cosmology Telescope released the clearest images of the CMB ever, with 5 times the resolution of previous maps. They even captured its polarization, the subtle orientation of its light waves, which reveals how matter moved in the young universe. Before we knew where things were, says ACT's director, Dr. Suzanne Staggs. Now we see how they're moving. These details help answer fundamental questions about how the cosmos evolved from simplicity to complexity, how matter clumped into galaxies and stars, the cosmic dawn after recombination. The universe entered a dark age, no new light, no stars until roughly 100 to 200 million years later, when the first stars, called population 3 stars, ignited. Massive and short-lived, they began shaping galaxies. Thanks to the James Webb Space Telescope, JWST, launched in 2021. We're now seeing this cosmic dawn for the first time. In 2025, JWST spotted Mumsy 1-4, the most distant known galaxy, from just 280 million years after the Big Bang. These early galaxies are brighter and more numerous than expected, raising a puzzle. How did such massive systems form so quickly? Are our models missing something? Colossal cosmic structures, Our theories predict that the largest structures should be no bigger than 1 billion light years. Yet in 2024, astronomers found the Big Ring, spanning 1.3 billion light years. Near another giant, the giant arc stretching 3.3 billion light years. Some scientists suspect these megastructures hint at new physics, perhaps exotic processes in the early universe, or even signs of a universe before ours, as proposed by Nobel laureate Sir Roger Penrose. Dark energy and dark matter under question in 1998. Astronomers discovered that the universe's expansion is accelerating, driven by an unknown force dubbed dark energy. It makes up 68% of the cosmos, yet we still don't know what it is. In 2025, data from the DESI survey suggested that dark energy may be weakening over time, possibly changing the universe's ultimate fate. Meanwhile, dark matter, the invisible scaffold for galaxies, remains undetected despite decades of searching, prompting radical new models like Dr. Richard Liu's 2025 proposal that the universe may have experienced multiple mini-bangs, not just one big bang, before the bang. Some theories suggest the Big Bang was not the ultimate beginning. Penrose's conformal cyclic cosmology envisions an endless series of universes, each giving birth to the next. Others, like loop quantum cosmology, imagine a big bounce, where a previous universe collapsed and rebounded into ours. If dark energy weakens and gravity takes over, our universe might one day collapse in a big crunch, sparking yet another big banger cosmic cycle without end. The frontier of the unknown. For now, the question what came before the Big Bang remains unanswered. We may never observe it directly, but indirect clues hidden in the CMB, in galaxy maps, or in future quantum gravity, theorists could one day reveal the truth. The Big Bang may have been a beginning, but perhaps not the beginning. And the story of our universe may stretch far further than we've ever imagined.